Hello guys, welcome to Learn with Venky. Today we will see how to find stress on the deformation of a axially loaded member. This we took now circular cross section rod. So you can see a small example here. We have a circular cross section rod which is fixed in the left hand side. On the right hand side, we are applying load about 10,000 Newton. So the length of this rod is 200 mm. The material I am using here, steel 210 gigapascal length modulus. The results I am getting from the formulas like analytical formulas PL by AE and force by area. I'm getting the stress and the deformation. So we will see the same analysis in HyperMesh. We will compare the results. So let's move on to HyperMesh. Now the interface of HyperMesh is like this. Maybe you may here or here, but default you have to be in Sketch. So now, if you didn't found this model browser, click on this view button and select the model browser. So now we are in HyperMesh. Now we will create a material first. Name it whatever you want. I am naming it as steel because I am giving the properties of steel. We just click on the default. It is having the structural steel values. Just confirm those values. If you want, you can change the values. So now I'm confirming the first four values and I will close this one. So now my material is defined. So now after material, you will draw a sketch. Select here new sketch option and here select the top and select the plane here and click on make it all zero and click on create. So now my plane is created. Now I will draw this one. Cylindrical shape rod. You may feel like you can import from any 3D like Fusion or CAD software. So the rod which is having here, which is a 1D element. So we have to create a 1D element and we have to perform the analysis. So now we'll create a line like this, which is about 200 mm. And see here a dimension, you have to click on this dimension and you have to give the dimension 200. Then from this into this end is 100. Now you can clearly see the line. Now line has been created. Now we have to move to 1D. We have to click on the beam section. And if you want, you can name quick circular or you can leave like same. So now see, it should be standard. Then what we are finding the rod. The rod is having a circular cross section. Now you can see the radius. It is radius. We need diameter. So you change this 10 mm into 5 mm and click on enter and close this window. Our section has been created. The circular section has been created. After this, we have to create a property. Create property. If not official, it is p-rod. The material is steel. Click on OK. The beam section, this one. Now close this window. Now we have created the material property and the geometry. Now we have to define this component, this property. Go to property here and click on the property, this one, and press OK. Now close this window. Now everything has been done. The modeling has been completed. Now we have to mesh this component. So you can see here only mesh option, line mesh. Select this. You can you can click on like this, or else you can select from here. Now the element size. You may feel like which element size I have to give. So usually for a line body, we need to split them into 20 elements. So you can see it is default taking 10 element size, which is the elements we are getting is 20. Now I need more accurate. I will give 5 mm. More than 5 mm, it is waste of time. So now I have given the 4 mm element size. I will click on here, edit element geometry. Should be rod. You can see the rod here. and select the rod property, this one, and close this one. So now you can see 40 elements has came. Now click on tick mark here. Now you can see the 40 elements has been created in the left hand side. Now meshing is completed. The pre-processing has been completed. Now we have to give the boundary conditions and we have to analyze this one. Click on analyze button and select the constraint first. Select the leftmost node. Click on tick mark. For fixed one, you can see here we have given the left side fixed. So it should be all the degrees of freedom will be arrested. You have to check all the degrees of freedom and create. Close. So you can see a triangle has been visible here. So it is constrained. So now here you have to select the rightmost node, tick here, and here you can see you have to give in x direction 1 and remaining all directions 0 because there is no force applying here. You have to give 10,000 Newton's force, which we have discussed here. Then create. So you can see the direction of force is away from the cross section. So now if you want to visualize this one in 3D, click on this one and again go here and click on this one. You can see our rod. Okay. Now I will click on this analyze button. So everything is done. We need to just analyze this one. But before that, I have to do one small step. Click on create again, create load step. And if you want, you can name or leave like this. This should be linear static. And SPC, you have to define which we are created, the constraints and the loads. And that's all. We will get the results now. Close this one. The load steps and subcase has been defined. Now click on analyze button and give any name like rod axial stress. Now save. We'll ask something. Should be all standard, preserve and export. So now the Altair console has been solved our analysis. It will ask to run. So you can see we got the pop-up message and also has been completed without any errors. If you click on this results tab, now you can see we are entered into hyperview window. Default it will show like this in isometric view. We need the top view like this, and you have to see the results. You have to click on the contour, and you can give next or max same because there is no force in any direction, only in x direction. So we need x direction, then apply. You can see the displacement, the maximum displacement here 1.31, 1.213 e power minus 1. That means 0.121. We will see our results, which are calculated by using formula. We are getting 0.121 mm. So the deformation we are getting and in HyperMesh both are same. So then after displacement, we will see the stresses. So you can see there is only one stress acting, which is axially. Then click on apply. Stress we are getting 1.273 e power 2. That means 127.3. So now we will see in analytical we are getting 127.3. So now this stress also matching. So now we have compared the results. We are getting similar results. If we found any deviation in this result, it may be because of meshing. So now if you want to visualize the animation, you have to click on the deformation here. It should be value should give around 15 or 20. Then apply. You can visualize the deformation here. It is moving in this direction. So the graphic properties in Hyper-V are little outward, like so it is not as good interface as in HyperMesh. So we are getting the correct values, but maybe the graphic properties are not so good. So now, uh, hope this video might be helpful for you. So for more interesting videos, please do subscribe, like, learn with Venky. Thank you.